Hello everyone, welcome to Gurudev Academy. I am Dr. Sridhar, Neet faculty. So today I am going to discuss Neet 2025 Chemistry Paper 3 discussion in live streaming. Okay, well, see, I would like to go for the first question, question number 46. Yes, read the question. Propane 1-ol and propane 2-ol can be best distinguished by with method. So they given the four option in which we have to select the best method to distinguish the 1 propanol and 2 propanol. Yes, the best method I am going to say as that is C option. Because why? What is the reason for that one? The oxidation by heating with copper with acidic dichromate solution followed by the reaction with Fehling solution is the best answer, because Fehling solution is a weak oxidizing agent. Fehling solution, it is a weak oxidizing agent. It oxidizes the only aldehydes, not ketone. Okay, well, here the copper is the one which can convert only what that is aldehydes. So that's the reason why, okay, now that propanol and 1 propanol and 2 propanol can be distinguished by the option C. Because 1 propanol, when it is undergo oxidation, it will use carboxylic acids, and 2 propanol, when it is undergo oxidation, it will use what? Ketones. Okay, well, so compare with all option. Option A is the best answer for this one. That's it. Well, go to the next question. The bond length of HCl is, that is a 2.9 into 10 to the power of minus 10 meter. The percentage of the ionic character of HCl. So if the measured dipole moment is 6.226 into 10 to the power of minus 30 centimeter. So here they given bond length of the HCl and also dipole moment they given. They are asking the percentage of the ionic character. So the percentage of ionic character is equal to mu of the experimental value divided by mu of the calculated value. Okay, see, they given what here, the dipole moment they given. The dipole moment, it is nothing but as what? Mu of the expected experiment value, that is equal to mu of the experiment value, that is a 6 point, that is a 6 point, how much? 6.226 into 10 to the power of minus 30 divided by, I want the mu of calculated. That mu of calculated is nothing but as a charge into what? Distance. What is the charge of the here? That is 1.6 into 10 to the power of minus 19 into the distance meters they given 2.1 into, sorry, 2.9, this is 2.9 into 10 to the power of minus 10. 2.9 into 10 to the power of minus 10. See, which is on simplifying, I am going to get the value, that is 4.64 into 10 to the power of minus 29 it will become. 10 to the power of minus 29 it will become. Now substitute the value for this one here, that is a 4.64 into 4.64 into 10 to the power of minus 29. To, if you want the percentage, just multiply it by 100. So this concept is on simplified. Okay, na? Then we are going to get, that is 34 into 10 to the power of minus 1. I will get it. By shifting the decimal on left side, I am going to get it as 13.4 here. 13.4 I am going to get. The 13.4 is the ionic character. So the nearest value for this one is how much here? 17. So this approximately nearer will be what? 17%. So option C is the right answer for the question here. Okay. Go to the next problem here. Okay. Well, go to the next problem. A compound that gives positive iodoform test. So which compound will give the positive iodoform test? The compound which containing what? Alpha carbon and alpha hydrogen should be there. That component will give only positive iodoform test. So among these here, okay, here option B will be become what? Iodoform test it will give for positive test, because here they given, sorry, that is CH3, C double bond O, CH2, then CH2, CH2, CH3. In this molecule, in 2-propanol, the carbonyl carbon, adjacent carbon, it is having one alpha carbon and is having alpha hydrogen. Hence, option 2 will be the right answer. Well, so here option B is the right answer for the question. Option B is the right answer for the question. Well, go to the next one. Question number 49. Reaction of ethyl formate with excess of CH3MgI followed by the hydrolysis gives, which is the molecule it forms. So for that one we need to write the reaction. When ethyl formate nothing but as HC double bond O, this is a C2H5. This is the ethyl formate. When this ethyl formate is treated with the, that is a CH3MgI, that is a Grignard reagent, okay na, which is further followed by the hydrolysis. Okay, first I will make this one. Grignard reagent, when dissociate, Mg become a plus charge and methyl become what? A negative charge. So this here oxygen is partially negative, carbon is partially positive. That negative charge attract here, positive charge attract here. So resulting in the formation of HCO, here it will forms MgI, and here as usual O, C2H5, and here there is a formation of CH3 will takes place. Now this molecule is further undergo hydrolysis. Now this molecule further undergo hydrolysis. The addition of water takes place. So now here this bond is undergo breakdown. That OH attached here and H attached here. So resulting in the formation of HCOH and here O, C2H5. And here this is water CH3, which is formed here. Okay, here what happens here? In this one, the oxygen containing lone pair of electron, okay, donate electrons here. Okay, 1 second. Instead of following 2 steps, just directly I will discuss a single step here. Yeah. Here the oxygen containing a lone pair of electron, it donates the electrons here, and these pi electrons are just eliminated out here. So resulting in the formation of here, we can get that is HC, here that is a CH3, okay, and here I can get it as what? A double bond. That is like this acetaldehyde we are going to get it along with the elimination of C2H5O Mg. This whole complete molecule is eliminated. Just I get it by a single step. Now this Acetaldehyde is further treated with again one more molecule of what? CH3MgI. This acetaldehyde further undergo reacted with one more Grignard reagent, so resulting in the formation of, that is HC, here one more CH3, here one more CH3, then I am going to get it what here? The OH it forms. Like this I can get the isopropyl alcohol. I can get the what? Isopropyl alcohol. I am going to get it here. Okay, yes, fine. So here one first that ester treated with the Grignard reagent, it will give aldehyde. This aldehyde further undergo treated with Grignard reagent gives what? Isopropyl alcohol. So option B is the right answer for the question here. Okay, well, fine. Now go to the question number next. Question number 50. An organic compound containing the carbon, hydrogen and nitrogen having the percentage is 40, 13.33 and 46.67 respectively, and its empirical formula may be. So they're asking the empirical formula. So they given the elements. Which are those elements? The carbon, hydrogen and nitrogen they given. What is the percentage they given? Carbon will be 40%, hydrogen will be 13.33%, and then nitrogen will be 46.67%. Next, if you want to solve this one, we should know the atomic mass. That atomic mass of carbon is 12, hydrogen is 1, nitrogen is 14. Now you get the ratio. Ratio nothing but as percentage composition divided by atomic mass. So here 40 divided by 12, 13.33 divided by 1, and 46.67 divided by 14. Which is on simplification, we can get here 3.33, 13.33, okay, and here also 3.33 I will get. Now you can go for the simplest ratio. Now we can go for the simplest ratio. Simplest ratio is which is the least value that we can make it dividing with for all. 13.33 divided by 3.33, 3.33 divided by 3.33. It is on cancelling, I will get 1. It is cancelling, I am going to get 4. Okay, and 13.33 by 4, 33 means 4, and here it is cancelling by 1. So there will be a carbon 1, hydrogen 4, and there is a nitrogen 1. This is the simplest ratio is the what? Empirical formula. Yes, which is answer right now here? That C4. CH4N, nothing but as option C is the right answer for the question here. Well, go to the next one. That question number 51. A compound of molecular formula, that is C8H8O2, reacts with acetophenone. React with the acetophenone to form a single cross aldol product in the presence of base. Okay, next. The same compound on reacting with concentrated NaOH, benzyl alcohol is formed as one of the product, the structure of the compound. Okay, so we can get the benzyl alcohol from which of the molecule when it is treated with the NaOH? Yes, it is one of the easiest concept. See here, this molecule treated with the acetophenone, it undergo cross aldol condensation, gives a single product. So then which is the molecule? Yes, when I take that aldehyde, okay, na, along with this molecule treated with the benzophenone. Benzophenone nothing but as C double bond or one side containing a benzene and another containing is a what? Alkyl group. So this is the alpha hydrogen containing carbon in the benzophenone treated with what? Aldehyde group. So just for making a easy purpose, just I am going to make a correction here. So now here this CH3 I am going to write it as what? CH2. See, when the molecule A is treated with the benzophenone in the presence of a base, what happens here? This 2 hydrogen and this oxygen is combined together to forms, okay, unsaturated beta hydroxy and alpha beta unsaturated hydrocarbons it forms. That is benzene, here CH double bond CH single bond, C double bond O, benzene it forms here, and along with there is a formation of the CS rear. Like this, okay, this first molecule, okay, react with the acetophenone in the presence of base, it forms a single cross aldol molecule. Single cross aldol molecules is produces. Next, this molecule is further treated with NaOH. This molecule further treated with the NaOH. What it forms? It forms the benzyl alcohol. This is OCH3 along with formation of the OH. It forms the benzyl alcohol. Okay, yes, there's benzyl alcohol. Yes, of course, here it forms a benzyl alcohol. Hence, option A will give right answer for this following question. Well, guys, go to the next question then. Question number 52. Well, for a concentrated solution of weak electrolyte, that is AXBY of concentration of C, the degree of dissociation, that is alpha is given as. So we need to calculate the alpha for this one. So they given here AX and BY molecule. When this molecule is an undergo dissociation, that is X, that Y number of, that is here X number of A to the power of Y plus and Y number of B to the power of X minus ions it forms. So if you go for the degree of dissociation, this is 1 minus alpha and this is what alpha C and this is what alpha C. Okay, well, so now initially at equilibrium, so this one I will take it later. Initially at equilibrium. Okay, now then here what is alpha? Alpha is called as what? A degree of dissociation. Alpha is a degree of dissociation. Alpha is the degree of dissociation. So now calculate the alpha. For this one equilibrium constant, that is K equilibrium is equal to, that is alpha C, how many numbers? X moles are there, that is alpha into C into X to the power of X and alpha into C into Y to the power of Y, all divided by C into 1 minus alpha. So here we know that for a weak electrolyte, 1 minus alpha is almost all equal to what? 1. So it's very, very negligible. It's small and it's very, very negligible. Then what is the alpha from this equation? Okay, na, on which is this equation which is on further simplification, I am going to get the alpha. Then final expression for this one, alpha is equal to, that is K equilibrium divided by C to the power of X plus Y, okay, na, minus 1 into X to the power of X and Y to the power of Y, all to the power 1 divided by X plus Y. So this is the mathematical expression we are going to get for the degree of dissociation from this equation here. So here the C answer is the right answer for the question. Well, go to the next problem then. Well, so given below two statements, that is a question number 53. Which are those two statements? Statement 1, methyl orange is a weak acid. Okay, actually it's a wrong statement because methyl orange is not a weak acid, it is a what? Weak base. It is a what? A weak base. Statement 1 is itself is a wrong. Okay, now it is a weak base. It is one. Statement 1 is itself is a wrong. Next, go to the next one. Statement 2, the benzonoid forms methyl orange is more intensive, deeply colored than the quinide form. See, the benzonoid forms a methyl orange is more intensive. It is not form more intensive. Actually, it will give yellow color, and that this one the quinide it forms a red color. Okay, The benzoate forms of methyl orange is more intensive. It is not form more intensive. Actually, it forms in yellow color. And the color then that quinoid it forms as a red color. So here it is also incorrect statement. So here both statement 1 and statements are incorrect. Hence option A is the right answer for the question. Next, go to the question number 54. Okay. Well, so which of the following major product is formed when 2-bromobutane is treated with alcoholic KOH? So 2-bromobutane is treated with alcoholic KOH. Which of the following compound is formed? So that is the question here. So here we need to solve this question by taking a simple, which is the reactant we need to take? That is 2-bromobutane. So 2-bromobutane nothing but as CH3, here 2-bromobutane. Yes. Say then this 2-bromobutane, when it is treated with the alcoholic KOH, it is an undergo elimination reactions takes place by following the Sedzhoff rule. By following the Sedzhoff rule. That's the reason why this Br is easily eliminated with K to form elimination of KBr takes place. Elimination of what? KBr takes place. So result in the formation of CH3, CH, and the formation of carbocation takes place here. This carbocation further treated with OH and the H plus ion which is eliminated from this carbon atom, resulting in the formation of a CH3 CH double bond, CH single bond, CH3. Like this it forms. Now what we are going to get it here? Whether we are going to get as a 2-butanol? No. 1-butene? No. 1-butanol? No. Trans-2-butene? Yes, of course, we are going to get it as a trans-2-butene. I am going to get it as a product. Answer. Option D is the what? Right answer for this question here. Well, go to the next question. Question number 55. Compound formed by electrolysis of mixture of ethanol and NaCl. So, if you take the ethanol, that is C2H5OH and NaCl. Okay, now, the which compound is formed by the electrolysis of mixture of ethanol and NaCl? See, this ethanol, it is having a covalent in nature, or a covalent bond it is having. That's the reason why it does not undergo electrolysis. Whereas in case of NaCl, it is an ionic molecule. This NaCl dissociated into Na plus and Cl minus. So it gives the more number of ions. NaCl when dissolved in water, it gives the 2 number of Na plus and Cl minus. As a result, number of ions are increases. And moreover, this Cl minus is easily undergo reaction to gives what? Cl2 during the electrolysis. Okay, Cl minus is an undergo easily converted into Cl2 during the electrolysis. Hence, option C is the right answer for the question here. Okay, well, go to the next problem then. Question number 56. Which of the following oxyacids of phosphorus is a reducing agent and monobasic? Which one is monobasic? Monobasic means the acid which gives one H plus ion is called as monobasic. Well, here which is the molecule is having ability to give one H plus ion? The compound which containing one OH minus here, that is H2, okay, PO3, H2, PO3, sorry, this is H3, this is what? H3, PO, I can take it as 2, H3PO2, it can forms one OH minus ion, that is phosphorus is present at the center, and this phosphorus it is bonded with a 3 hydrogen, and this phosphorus is having make a double bond with one oxygen, and this phosphorus is having only one OH. See, phosphorus is bonded with only one OH, okay, and this H, so from the OH, H can be easily eliminated as an H plus. So hence this molecule is act as a monobasic and also act as a reducing agent. Hence option C is the right answer for the question here. Well, go to the next question then. Well, fine. Question number 57. Match the column 1 with column 2 and mark the appropriate choice. See, we need to match the column 1 with the column 2 here. Okay, well, fine. See what they given in the column 1. See, in column 1, FEOH taken twice. Okay, na? FEOH taken twice they given here. Okay, well, fine. So what is the KSP value for this one? So I will calculate here itself. That is FeOH taken twice. So this molecule when dissociated, it will become Fe plus 3 and along with the 3 OH minus ions here. For solubility here 1S and here 3S. If you go for the simplification, that is KSP is equal to S to the power of 1 and 3S to the power of 3. Then what is the calculated answer we are going to get it here? That is 3 3s are 9, 9 3s are 27. 27 S cube it will form. 27 S cube it forms. Okay, see for the option A, it will forms the second one. Okay, it will form the second one. Next, I will go for Ag2 CrO4. When this molecule is dissociated, it forms a 2Ag plus 1 along with CrO minus. Here its solubility is 2S and here there is a 1S. Now, what about the KSP? KSP is equal to 2S, that is the 2S square into 1S. 2 2s are 4, 4 plus that is 4S cube. The answer is 4S cube. So 4S cube I can find here, that is 4S cube. Okay, so for second one, so for the first one it is for A it is 2, for A it is a 2, for B it is fourth one. So on ultimately calculation we can get the option B is the right answer, because A is given only A is equal A for the option A, second one is the correct, and in the given all four option B is having only, A is having only that the second one, and B is having a fourth one, as the right option is a B here. Well, go to the next one. An unsaturated hydrocarbon was treated with ozone and resulting ozonide on hydrolysis gives 2-pentanone and acetaldehyde. So acetaldehyde 2-pentanone is the product which is formed by treating a ozonolysis. Then what is the structure of the alkene? What is the structure of the alkene? It's a very simple. So here we need to get the molecule as 2-pentanone and acetaldehyde. 2-pentanone and acetaldehyde, how can I get here? See, that is 2-pentanone and acetaldehyde. C double bond O, that is CH3, CH3. This is a pentanone, and acetaldehyde as this is the acetaldehyde. This is the product which is obtained from the ozonolysis by treated with O3. Then what is the reactant species? Then what is the reactant? It's very simple. If you remove these two oxygen, then what is the reactant is produced here? C. Here there is a 1 CS3. Here there is a 1 CS3. Make a double bond here, and here H and CS3. So this is the reactant molecule. When this reactant molecule react with O3, it undergo ozonolysis, gives these two products. So which is the right answer here now? Yes. Okay. 1 second. This is pentanone. No, pentanone matters. Here that C3H7. Here it becomes C3H7. Yes, right. So now here option B is the right answer for the question here. Well, go to the next question then. The enthalpy change in entropy for the fusion of 1 mole of ice is, melting point of the ice they given 273, and molar enthalpy of fusion of ice is 6.0 kilojoule per mole. Okay, see they're asking what the change in entropy, that is nothing but as delta S is equal to how much? If they given as enthalpy of the fusion, that is a delta H of the fusion is equal to 6.0 kilojoule per mole. So this one I am converted into kilo, I will remove it. Then 6.0 into 10 to the power of what here? I am going to take it as 3 joules per mole. So we need to calculate the water delta S. Then what is the first one? It's a very simple. The enthalpy of fusion is equal to, that is called as delta, the entropy of the fusion is equal to enthalpy of the fusion divided by temperature. Here we have the delta H value, that is 6.0 into 10 to the power of 3 divided by what is the temperature they given. So 273 given, already they given, just to put the value as a 273. So 6.0 divided by 273 into 10 to the power of 3, which is on simplification, I am going to get the value, that is 21.978. 21.978, that is joule per mole. This is the entropy I am going to get. So here 21.98, it is present in the option C, and C option is the right answer for the question here. Well, go to the next question, question number 60. The standard electrode potential, that is M plus 3 bar M plus 2 for vanadium, chromium, manganese and cobalts are in terms of minus 0.26 volt, minus 0.41 volt, plus 1.57 volt and plus 1.97 volt respectively. The metal ion which can be liberate hydrogen from dilute acids. So which metal ion when react with dilute acids which gives H plus ions? It's a very simple basic concept. So greater the means the species which is having a negative reduction potential will easily liberate the hydrogen from the dilute acids. So among these four metals, which metals having negative electrode potential? Yes, these are the two values, nothing but as vanadium it will shows minus 0.26 volts and chromium it will shows minus 0.41 volts. So these are the elements having negative electrode potential. These standard negative electrode potential elements easily liberates the hydrogen from the dilute acids. Hence the right answer is D, that is Ve plus V plus 2 and chromium plus 2 is the right answer for the question. Well, go to the question number 61. In the reaction 4P 3KOH plus 3H2O gives 3KH2PO2 and PH3. The phosphorus is either reduced, oxidized, neither reduced nor oxidized, or both reduced and oxidized. So we need to solve this one. Okay. Well, anyhow, look at here. This 4P, it is an undergo reaction with the 3KOH along with the 3 molecules of the water. It will give 3 molecules of KH2PO2 along with it forms as PH3. See, the oxidation state of the phosphorus is 0. And in case of PH3 it is minus 3. In case of the air it is minus 2 and here plus 1, here plus 1. 4 4s are minus 4, 4 2s are 2 2s are 4 and taking minus 4 and here minus 3 and here plus 1. Yes, the oxidation state of the phosphorus here in this case is plus 1. Dear all, it's very clearly evident that the phosphorus, okay, now when it undergo reaction, it oxidation changes from 0 to minus 3 and also its oxidation changes from 0 to plus 1. Here oxidation number is increase, here oxidation number is what? Decrease. This indicates phosphorus is undergo both oxidized as well as reduced. Hence option D is the right answer for the question. Well, now come to the point. Question number 62. In the following sequence of the following reaction, identify the final product. So we need to identify the final product. It's a very simple reaction. Look at here, guys. When there's a CH3MgBr, this is a Grignard reagent. When this Grignard reagent reacted with the cyclohexanone. So what happens here? It's a very simple thing. This is a positive charge, this is a negative charge, and when it break here, this is negative charge and this magnesium shows positive charge. This positive charge will go for the oxygen O minus and negative charge will go for the positive charge of the carbon. So resulting in the formation of like this the molecule takes place. Here there is a CH3 and here O, this is MgBr. Well, this molecule which is an undergo hydrolysis, this molecule which is further undergo hydrolysis. When this molecule is further undergo hydrolysis, so what happens here? Here this bond is undergo breakdown. OH and H forms here. Ultimately, I can get this molecule as like this. This is CH3 and this is OH. This is a compound A. This is a compound A. This A product is reacted with HBr. This A molecule is reacted with HBr. See, this H and this OH combined together, elimination of water, then ultimately I can get the component as here CH3 and Br. This is the component B. This is the component B I got here. When this B is reacted with magnesium in ether, this B is reacted with magnesium in ether. Here it forms the Grignard reagent takes place. Here it forms the water Grignard reagent. This is MgBr takes place. This is the component C. When this component C is further treated with, this is water CS3CHO followed by water hydronium ion takes place. Ultimately, on simplifying, I'm going to get this one. Okay, I'm going to get this CH3. Okay, this is CH3. Okay, then CHOH CH3. So this Grignard reagent react with aldehyde, it forms a secondary alcohol. It forms a secondary alcohol. Hence, so the alcohol which is formed from here. So which is the right answer for this one? So here option A is the right answer for this question here. Okay, na? So here directly I can't predict the answer. We need to write the reaction and we need to solve this one. Then only we can get the answer. Well, fine. So option A is the right answer for this question. Well, then go to the next question. Well, given below are two statements. One is labeled as assertion, another labeled as a reason. Okay. Well, so read the assertion. Assertion. Cu plus 2 ion in water is more stable than the Cu plus 1. So whether assertion is correct or false, that we need to find out here. Okay, now read the question one more. The Cu plus 2 ion in water is more stable than the Cu plus 1. Yes, the statement 1 is correct. Cu plus 2 is more stable than Cu plus 1. Statement that statement is correct means assertion is correct. Go to the reason. Enthalpy of hydration of Cu plus 2 is much lesser than that of Cu plus 1. Yes, of course. Enthalpy of hydration of Cu plus 2 is much less than the Cu plus 1. Because of that reason itself, Cu plus 2 in water is more stable. So even reason is also correct. And that reason is the correct explanation for the assertion. So angagi, so answer A, both A and R is correct and R is the correct explanation for the assertion. Option A is the right answer for the question. Well, go to the next. A binary liquid solution is prepared by mixing of N-heptane and ethanol. Which one of the following statement is correct regarding the behavior of the solution? So I'm going to take it as that is N-heptane and ethanol. So N-heptane and ethanol. Okay, na. So these by mixing of this one, I'm going to get here the solution. So it is an example for the non-ideal solution because here N-heptane it belongs to ideal and ethanol is become non-ideal. Okay, na. So the combination of these two, it will shows the non-ideal solution. And in N-heptane and ethanol, the attraction will be less. If the attraction will be less, then it will shows the positive deviation. Hence, the solution is a non-ideal and shows the positive deviation from the Raoult's law. So B option is the right answer for the question here. Well, go to the next problem. Uncertainty in the position of an electron having mass this much, moving with a velocity is this much, accurate up to 0.001 percentage will be, then h divided by 4 pi is uncertainty expression where h is equal to this. So they're asking the uncertainty position. Uncertainty position nothing but as delta x is equal to what? So for this one, delta x into m into delta v equal or greater than h divided by 4 pi. So I need to calculate delta x. Then delta x, keep it here. Delta x is equal or greater than h divided by 4 pi into m into delta v. Okay. So we need to substitute the value for this one. Then substitute the value here. That is delta x is equal to h value nothing but as 6.626 into 10 to the power of minus 27 divided by 4 pi value, that is 3.142 into m value, that mass they given here, that is how much here, 9.1 into 10 to the power of minus 28 gram into velocity, the delta v, velocity they given 3 into 10 to the power of 4, 3 into 10 to the power of 4, along with what is the accurate percentage of this one? 0.001 percentage. 0.001. To remove the percentage I will put 100. So here, simplifying all these values, ultimately I am going to get the value as, that is delta x is equal to 1.92 centimeter. But here they given as 1.93, then I can consider it as approximately 1.93 centimeter. So option C is the right answer for the question here. Okay. Well, did you follow now? Well, move to the next problem then. Yes. See what they given here. The rate law of a chemical reaction, that is 2NO plus O2 gives 2NO2, is given as a rate equation, that is R is equal to K into NO to the power of square into O2. If the volume of the reaction of the vessel is increased by 4 times of its initial value, or the initial volume, then rate of the reaction. See, if the volume of the reaction is increased by 4 times in its initial value, then what about the volume of the reaction? It is decreased by 4 times. It is decreased by what? 4 times. Okay, anyhow, the given rate, that is R1, already they given, that R1 is equal to K into NO, all to the power of what? 2 into O2, all to the power of 1. This is a given value. If volume is increased by 4 times, that indicates volume is decreased by, if the volume is increased by 4 times of its initial nothing but as, its volume is decreased by 1/4 of its initial value. Then rate constant, then rate, that is R2 is equal to K into 1 divided by 4 into NO, all to the power of what? 2 into 1/4 of O2, all to the power of 1, which is simplification. Okay, now what it from K into 1 divided by 4 square nothing but 16. 1 divided by 16 NO. Okay, NO2 here. Then I can take then 1 divided by what? 4 into what? O2. Take the common the value here. So then R is equal to K into what? 1 divided by 16 into 1 divided by 4 into what? NO all to the power of 2 and O2. So 16 fours are 1 divided by 64. 1 divided by what? 64. K into 1 divided by 64 times here. Okay. So where they given here? Yeah, first option itself they given. The value become 1 divided by 61 by 64th of the initial rate. So answer A is the right answer for the question here. Well, go to the next question. The equilibrium constant of the following redox reaction at 298 Kelvin is, that is 1 into 10 to the power of 8. The given reaction here, Fe plus 3 plus 2I minus is equilibrium the Fe plus 2 and I2. If standard reduction potential of iodine become as, iodide is 0.54 volts, then what is the standard reduction potential of the Fe plus 2? In this equation, They're asking the electrode potential of the either cathode or anode. That I will going to discuss from this equation. Look at here. Fe plus 3 is converted into Fe plus 2. Here it is an undergo reduction. It is an undergo reduction. So Fe plus 2 plus 3 to Fe plus 2. It is an undergo reduction. So reduction it acts as at a cathode. Next, I minus 1 become what? I2. It is an undergo oxidation. It is an undergo what? Oxidation. Oxidation takes place at anode. Okay. Here, what they asked here, what is the standard reduction potential? Standard reduction potential here they are asking the E cathode. So we know that E naught cell is equal to E cathode minus E naught of anode Here they given the iodine value, that is the standard reduction potential of iodine become as 0.54. So the iodine value they given, that is anode, that is 0.54 value they given, and we need to calculate the E naught of cathode. We need to calculate this one, and I don't know value of E naught cell. That E naught cell value I need to calculate from the equilibrium constant. Okay, so ultimately I will simplify this one. E naught cathode is equal to E naught cell plus 0.54. Okay, so I will calculate the E naught cell with the help of the equilibrium constant. That is E naught cell is equal to equilibrium constant value formula, that is 2.303 RT divided by NF into log of equilibrium constant. E naught cell is equal to 2.303 into R value, that is how much? You can substitute 8.314 into temperature, how much they given? 298 divided by, okay, number of electrons, how many transferred here? So 2 electrons, that is a 2 into Faraday, 96,000 what? 500, which is on simplification. I will get the value as okay, sorry, I need to substitute the log values also. That is log of how much here? 1 into 10 to the power of 8. 1 into 10 to the power of 8. So log 1 into 10 to the power of value, 10 to the power of 8 value is 8. Okay, na 8. So I will put the value again. That is a 2.303 into 8.314. 8.314 into 298 divided by 2 into 96,500 into 8, which is on multiplying and division. I am going to get the value as, that is 0.236 volts. This is the value of E naught cell. Then substitute the E naught cell value, that is 0.236, 236 plus 0.54. On addition, I am going to get the value is how much? That is 0.776 volt. So 0.77 nothing but as what? Answer C is the right answer for the question. Next, go to the question number 68. Statement 1. For every chemical reaction at equilibrium, standard Gibbs free energy is 0. Okay. Is it the statement is right or wrong? That we need to find out. For every chemical reaction at equilibrium, standard Gibbs free energy is 0. So it is a wrong statement. Okay, na? Here delta G is equal to 0, but delta G naught may be 0 or may not be 0. Hence, the first statement is wrong. Well, go to the second statement. So, the second statement, it shows that at constant temperature, pressure, the chemical reaction are spontaneous in the direction decreasing the Gibbs free energy. Yes, during the spontaneous delta G is what? Less than 0. That indicates decreasing the Gibbs free energy. So statement 2 is the right statement. So statement 1 is false, statement 2 is true. Answer D is the right answer for the question. Go to the next one. In the third period, the first ionization potential the first ionization potential of the order is, okay, here actually in third period the first ionization potential is the correct for this one is what? The sodium is having least, actually it's correct, phosphorus is having a very high because of the more electronegative and because of the lone pair of electron. So answer D is the right answer for the question here. Okay, well, go to the next problem then. Question number 70. What 70 question? It says that the ionic radii of the group 12 metals like zinc, cadmium and mercury are smaller than those of the group 2 metals because of the zinc, cadmium and mercury have, which is having what? Because of the 10 electrons which are what? Strongly shielded in their nuclear charge. Okay, now because of the strongly fielded here. So here for the question number, electrons are strongly attracted. See that 3d orbital is having 10 in case of a zinc, in 4d orbital 10 electrons in case of the cadmium, and 5d orbital is having 10 electrons in case of the mercury. Because of their outermost orbital is completely filled, hence these electrons which are strongly attracted towards the nucleus. When they are strongly attracted towards the nucleus, the nuclear charge is become poor. Nuclear charge is become what? Poor. Hence option A is the right answer for the question here. Well, go to the next problem then. Question number 71. The enzyme which can catalyze the conversion of maltose into glucose. The maltose is which can converted into glucose by the enzyme that is called as maltase. Maltase is an enzyme. Well, go to the next question. In the reaction, that is A2 plus 3B2 gives 2AB3. The standard entropy is in kilojoule per mole of A2, B2 and AB3 are respectively. So S naught of A2, how much they given? S naught of A2 they given how much? 190 kilojoule per mole. Sorry, only joule per mole they given. Joule per Kelvin per mole. And S naught of that is B2 they given. How much they given here? 130 they given here. 130 joule per Kelvin per mole. And for AB3, S naught of AB3 they given 195 they given as a standard enthalpy is for this one. Well, the standard enthalpy change for the reaction, that how much here? The standard nothing but as yesterday, that is delta S naught of this one is minus, that is how much? S naught is, that is minus 95 kilojoule per mole they given. The temperature at which the reaction attains equilibrium. The temperature at which the reaction attains equilibrium. So here we need to calculate the temperature. What is the temperature? That is temperature is equal to what? That is delta S, delta H divided by what? The temperature is equal to what? Delta H naught divided by delta S. How I am going to take this value here? It's a very simple. See, delta G is equal to delta H naught minus T into delta S. At equilibrium, delta G is equal to 0. Okay. Now what is the final expression? Then delta H is equal to T into delta S. Then T is equal to delta H naught divided by delta S naught. So delta H naught value they given already minus 95. This is what? Minus 95. So I need to get delta S value. So what is the delta S value? The delta S value I need to calculate it from this equation. I need to calculate it from this equation. Okay. So they given the equation that is what? A2 plus 3B2 giving rise to 2AB2. Okay. Here how many are there? Only 1. So what is the delta enthalpy? That is the product minus reactant. How many products are there? 2 product. AB2 value is how much they given? 195. 195. Okay, now minus. There are reactant. A2 will be there. A2 how much will be there? That is 190 into 1 plus 3 into how much? 130. 130. Which is on further simplification. Which is on further simplification. How much I am going to get? This is what? 390 minus 580 on whole and soul on simplification. Ultimately, 390 minus 580 I am going to get as a minus 190 kilojoule. So I got the delta S value minus 190. Minus minus will get cancelled. 95 divided by 190, which is on simplification. So I am going to get it as what? 500. Okay. See, the answer they given in terms of a percentage. So I need to multiply 100. So 95 into 100 divided by 190, which is on simplification, I will get it as what? Kelvin. Why I take in what? Here Kelvin they given. Kelvin nothing but as 1000. Yes. So because the values they given in terms of kilojoule, the value of kilo is 1000. So 95 into 1000 divided by 190, then which is on simplification, I am going to get this 500. So 500 Kelvin. Answer A is the right answer. Well, go to the next. Work done on an ideal gas in a cyclic, in a cylinder when it is compressed by external pressure in a single step is shown as. So this is the piston, okay, which is present in the cylinder. When by keeping the external pressure constant, when apply the pressure here, okay, the volume is changes. This is the volume as V1, this is the volume as V2. Then which of the following graph will show the work done? The graph which shows the work done, the volume changes from V1 to the V2 with respect to the A and B. Then area is equal to external pressure with a change in volume. So answer A is the right answer for the question. 24. For the reaction, that is MnO4, that is MnO4 minus 1 react with C2O4 minus 2 reacted with H plus. It gives Mn plus 2 and CO2 along with formation of H2. CO2 along with formation of H2. So this one we need to balance it. This one we need to balance it. This is option A, option B, option C, option D. See, oxidation state of the oxygen manganese is plus 7 and it changes to the plus 2. So now oxygen the manganese value that is undergo changing into plus 5. The plus 5 is the change in oxidation state. In oxide that is plus 2 will be there and here there will be plus 4 will be there. The change in oxidation state of the carbon is become what? Plus 2 here. So by on crisscross multiplying I am going to get the value here. So here I am going to put 2, here I am going to put 5. Here I am going to put what? 5. Because to match the loss and gain of electron multiplied by 2 here and multiplied by 5 here. Then I can say that manganese is having 2 and auxiliary ion is 5. So among this one, MnO4 is 2, C2O4 minus 2 is 5. Then ultimately, hydrogen ion is become what? 16. Option A is the right answer for the question. Go to the next one. Which one of the following has most nucleophilic nitrogen? So more nucleophile means more electron donating tendency containing nitrogen. Among all these, okay, the pyridine will have lone pair of electron donating tendency because in pyridine nitrogen is present by replacing the carbon, okay, which is not involving in resonance, hence it easily donates electron density more, hence it acts as a more nucleophile. Hence option A is the right answer for the question here. Next, go to the second experiment 6. As a result of dissolution of NaCl in water, the entropy as NaCl when dissolved in water, it increases the number of the ions. As the number of the ions is increases, then entropy is also increases. Well, I'll go to the next one. Ammonia is a Lewis base and it forms complex with many of the cations. Which one of the following cation does not form the complex with ammonia? Yes. Usually D block elements will form a complex with the ligands. But here one of the element, see, gold, silver ion is a D block element, copper ion is a D block element, cadmium ion is a D block element, but lead is not belongs to D block element, it belongs to P block elements, hence it is not involving in the formation of complex. Okay, hence the right answer is D, that is lead. Well, go to the next question. Hemoglobin containing 0.334% of iron by weight. Next. Molecular weight of the hemoglobin is approximately 67,200 grams. Then the number of iron atoms present in one molecule. In one molecule of hemoglobin containing how many number of iron atoms? So first we should check the mass of the iron, that is weight of iron in 0.334% is equal to, that is 0.334% divided by, for the removal of percentage, 100, multiplied by its molecular mass, that is 67,200, which is on simplification. I am going to get the value, that is 224.45 grams I will get it. So 0.334% of iron in the hemoglobin will be containing this much of iron. So we know that 56 gram of iron containing one atom. Then 224.245 grams of iron containing how many atoms? This is X. Then X is equal to 224.45 multiplied by 1 divided by 56. 56 ones are 56 fours are. Means it containing 4 atoms. Means it containing is what? 4 atoms here. Well, go to the next one. Well, fine. Question number 79. Question number 79. Arrange the following compounds in the increasing order of their boiling point. Arrange the following compounds in the increasing order of their boiling point. This will be not there here. See, as we know that as the branches are increases, boiling points are decreases. As increasing the branch, decreasing in the boiling point. Here it is a long chain, and it is having more boiling point. That is the second option will have more boiling point. This is less branching. It is a very more number of branching. So third one is the least. Third one is the least boiling point. Second is the more. Because of the straight chain, boiling point more. It is more branched, less boiling point. Hence option C is the right answer. Option C is the right answer for the question. Go to the question number 80. Go to the question number 80. Okay. So in this one, we need to predict the answer. We need to predict the answer. So what is the question? Here the question number 80. The question is missed here. Just write the question here. That is CS3C triple bond C CS3. When it is treated with sodium in liquid ammonia. Sodium in liquid ammonia. It will give what? It will give what here? And this one, when it is treated with Lindlar catalyst. Lindlar catalyst. What is the product here? Yes, dear all, so as we know that when the molecule well, so dear all, here I will write the reaction when CH3, C triple bond, CH3, when this molecule is treated with sodium in liquid ammonia. Actually, we are going to get the trans product. We are going to get the what? trans product. Okay, na? So trans product nothing but as here the same groups which are present at the opposite side. The same groups which are present at the opposite side here. Okay. Next, when this same molecule when treated with a Lindlar catalyst, when treated with what? Lindlar catalyst, then it will give the what? Cis product. It will give the what? Cis product, that is C double bond C H CH3 CH3 H. Meanwhile, it means both that A and B product we are going to get it as one cis product and another is what? A trans product. And answer A is the right answer for the question. Well, I'll go to the next problem. For the Balmer series in the spectrum of hydrogen atom, that's mu bar is equal to RH into 1 divided by N1 square minus 1 divided by N2 square. The correct statement among the 1 to 4 is, so we need to find the correct statement for the option here. So here I am saying as wavelength decreases, the line of the series also converge. Yes. As the wavelength decreases, as the lines in the series are converges. Yes, it is the right statement. The integer n1 is equal to 2 in the Balmer series. Of course, in the Balmer series, n1 is equal to 2 and n2 is equal to 3, 4, 5 and up to infinity. Yes, statement 2 is also correct. The lines in the largest wavelength corresponds to the n2 is equal to 3. Yes, of course, obviously correct for the Lyman series. If n1 is equal to 2, then n2 is it may be 3, it may be 4, it may be 5. Ionization energy of hydrogen can be calculated from the wave number of these lines. No, it is not possible. So answer 1, 2, 3. The 3 points are correct. Hence option A, C is the right answer for the question. Go to the question number 82. When first ionization energy is plotted against the atomic number, the peak of curve is occupied by for which type of the molecules? It may be a what? Rare gases. Why? The first ionization energy plotted against the atomic number is peak curve, because the rare gases are there completely filled there in outermost or octet state. So because of the completely filled in their valence shell or valence orbitals, okay, now energy required become more. That's the reason why it is having a peak curve is highest. Hence the option B is the right answer for the question. Next, the most stable compound is. So the most stable compound, which one? Yes, the smaller the atomic radii of the cation and anion, then it shows the greater the stability. Yes, among these one, lithium is the common for all and fluorine is the smaller atomic radii of the another one. So it will shows the most stable compound, that is option A. Well, go to the question number 84. Germanium plus 2 compounds are powerful reducing agent, whereas Pb plus 4 compounds are strong oxidizing agent. This can be due to, so this can be due to the pronounced inert pair effect. This is because of the more pronounced inner pair effect in the lead than what? Germanium. So that's the reason why, okay, na, germanium is that powerful reducing agent, okay, na, and Pb is a strong oxidizing agent because of more pronounced inert pair effect in lead than germanium. Well, option D is the right answer for this. Go to the next one. For the chemical reaction at 27 degrees Celsius, the activation energy is 600 R. Means I am going to write the given data. Activation energy is equal to what? 600 R. The ratio of the rate constant at 373 degrees Celsius to that of 27 degrees Celsius. That is the T1 is equal to 27 degrees Celsius and T2 is equal to 327 degrees Celsius. It is on conversion into Kelvin, 300 Kelvin, it is a 600 Kelvin. What they asked? The ratio of the rate constant they asked. The ratio of the rate constant nothing but as what? That is here I can say as K2 by K1 is equal to what? So this is the From the Arrhenius equation, I can solve this problem. Okay, na? That is ln of K2 by K1 is equal to A divided by what? 2.303. A divided by what? Okay, directly I will write. K2 by K1 is equal to A divided by R into 1 divided by T1 minus 1 divided by what? T2. Then substitute the value, that is ln of K2 by K1 is equal to E nothing but as already they given, that is a 600 R divided by R into 1 divided by what? T1 means 300 Kelvin minus what? 600 Kelvin. So which is on further on simplification, which is on further RR get cancelled, that is ln of K2 by K1 is equal to, which is on further simplification, 600. You take the common answer here, 600, that is 2 minus 1. So do the simplification. So here 600 will get cancelled, 2 minus 1 nothing but as 1. So here ln of K2 by K1 is equal to 1. Okay, so K2 by K1 is equal to e to the power of 1. So K2 by K1 nothing but as E, which is on removing ln, K2 is equal to E. So the right answer is C, that is E. Go to the question number 86. The set of numerical coefficients that balance the equation. When K2CrO4 react with HCl, it gives what? K2, that is Cr2O7 with KCl and H2O. Okay, so we need to balance the reaction. Okay, na? So here there are two chromiums, K2s are there. So sorry, here 2 plus 1, 3 are there. Here also there is only how many are there? 2 are there. So for balancing purpose here, just I am going to take the 2 here, means it become 4 here. Then 2 CLs are 2 here. Then it become, which one is 2, 2. Then here 1, 2, here 1. So option D is the right answer for the question. Go to the next question. In which of the following complex ion the central metal atom, the central metal ion is in the state of sp3d2 hybridization? Which is the molecule is having sp3d2 hybridization? So sp3d2 hybridization, here d orbital it comes on the next, at last. That indicates there should be a weak field ligand. Among these one, which is having weak field ligand? Strong field, and fluoride is a weak field. Hence, so weak field ligand will shows sp3d2 hybridization here. Hence, option A is the right answer. Without solving, I can solve here. Question number 88. Statement 1. During the flame test of a basic radical, few drops of HCl's are added to the salt. Of course, while doing the flame test, few drops of HCl's are added. Okay, now statement 1 is correct. Why that HCl is added? See, they given a statement 2. With HCl, metal salts are converted into metal chlorides which are more volatile. Yes, that's the right statement. When HCl is added to the metal, that metal reacts with HCl to form metal chloride. That metal chloride will show some volatile nature. That's the reason why it gives a good flame during the flame test. So here in the question number 88, okay, now both the statement 1 and 2 are correct, and statement 2 is the correct explanation of the statement 1. Well, go to the question number 89. Well, which of the following reaction does not heat the amine? When Rx react with the NH2, of course, it will give amine along with formation of HX, it will give amine. Then RCH double bond NOH, when it is undergo reduction, yes, of course, the hydrogens are here, it also gives amines. When RCN, when treated with water in the presence of H plus. Okay, actually when cyanide treated with water in the presence of H plus acidic condition, it will give carboxylic acid, so it will not give amines. Hence option C is the correct option. It does not give primary amines. Go to the last question. In the reaction, that is a 2x is gives Y, the concentration of the X is decreases from 3 moles to 2 mole per liter in 5 minutes. The rate of the reaction, that is R is equal to, I can say that is 1 by 2 into what? Dx divided by dt. Then R is equal to 1 by 2 into concentration of the reactant decreases from 3 to 2 with that is a time of what? 5 minutes. Just do the simplification. Now I am got 1 by 2, that is 3 minus 2 by 5, which is on simplification I am going to get it as a 0.1, which is I am going to get a 0.1, that is 0.1 mole per liter per minute. That is the right answer for the question. Okay. Yes, dear students, whatever the questions I discussed, these are the high level questions. Okay, now please go through these questions and try to solve this one. Okay, yes sir. Thank you for watching these videos. For more videos, please subscribe and put the bell icon. Okay, now to get the next videos. Okay, tomorrow we are coming with another one new paper. Please watch. Okay, thank you so much. Thank you.